Exercise 12 of Fundamentals of Mocha is mainly about looking at the 3D camera solve, but I also want to have a look at how we work with interlaced footage a bit more and some of the problems that can give us. So I'm going to start up a new project and I'm going to choose my clip and it's going to be called Shaking Train. This is an HD clip and I know that we do have interlacing on it. Now normally when we have an HD clip with interlacing, it's upper field first. So let's choose that there. As I said before, all the way back when, if we are working with interlaced footage, we need to let Mocha know straight away, right from the very start. Because if I go into my clip settings now, come to interlace, I can happily choose between upper and lower field first. But I can't turn separate fields off here. And likewise, I couldn't turn it on if I told Mocha that we were working with a progressive clip to begin with. So let's play this back. So we've got this interpreted as upper field first, and we can very easily see here the problems that we've got when we do a wrong interpretation. So this is just stuttering back and forth, back and forth, back and forth. So I can tell that something's wrong here. Now all I need to do is go into my clip and say this is lower field first. Come back into my track, we'll play that forwards again. And you can see we don't have those problems anymore. So if you do get a clip that you know is interlaced, but it's interlaced in a weird way that you don't expect it to be, you know, we can always change that later on very easily. So let's take a look at our clip here. It's a bit shaky, but that's all right. But I want to come in and I want to build up a quick 3D camera that I can use in another application. Now the 3D camera solver in Mocha isn't like a dedicated 3D match moving piece of software. What it does is it works out the relative movement based on the planar tracks that we create. And unlike dedicated 3D match moving software, we're not going to be able to input things like known distances and build up an accurate 100% accurate camera complete with point clouds and all of that stuff. But it's a good way of getting a nice, quick, easy 3D camera solve when you've got a shot in Mocha anyway, and you want to add that extra bit out of the data you've probably already tracked in anyway. Now, if we take a look, I'm just going to actually create a layer that I'm going to delete in a second, so I can go into my 3D camera solve. Now, if we have a look at the camera here, we've got different types of motion that we can track. We can track pan, tilt and zoom. We can track small parallax and large parallax. So what's the difference between these three? The pan, tilt or zoom is really designed for when we've got a fixed camera. So say for example a camera mounted on a static tripod, and the only movement that you've got going on with it is a pan, a tilt or a zoom. Makes sense really. If we have a moving camera, something like a handheld camera or on a dolly or crane, then we can start to use the parallax change cameras here, the small parallax or the large parallax cameras. And it's actually quite important to know the sort of motion that you've got before you even start to do any tracking, because the type of camera that you've got is going to affect what sort of tracks you want to build up, of course. So let's ditch this layer one here, and let's take a quick look back at the footage again, and we can see that this is a camera mounted on a tripod, being hit along the way as the zoom is changing up, or the being blown around by the wind. So we've got a few bounces going on, but essentially it's just a pan with a zoom change. Now if we're going to track this for a camera solve, then the pan, tilt and zoom only really needs one, well the minimum is one shape. And this shape should cover multiple planes. So it's not like we've been doing previously where if we wanted to track something, we need to track something that's coplanar, something like the front of the train here. No, actually what we want to track in this case is something almost the complete opposite. We want to track across multiple planes. So here, well, let's go crazy. Let's track basically the entire background here. So you don't get much more, non-coplanar, where we're going definitely over multiple different types of planes here. So we've got all the stuff in the foreground plus the stuff in the background here. And let's call this one background track. Or background is my favourite misspelling of this one. Yeah, so what sort of motion are we going to give this? Well, let's take another look at it here. I mean, with the panning camera, we do have a small amount of perspective shift. But how easy is that going to be to model? Well, let's turn perspective on and see what we get. And if we look through again here, about halfway through the clip, we've got a car coming in and ruining our shot. So I want to put a track map on that one. And this is going to be really easy. I'm going to do a track map without actually doing any tracking. So I'm just going to manually keyframe this. So let's come in. Let's change that color there. And we'll call this one track map. Got my auto keyframe on over down in the bottom right hand corner. Let's take it so it goes out of frame, and we'll just move our shape out along with it. Set my in point on the layer properties over on the left, and wait for it to go behind the train as well. Set my out point on the layer properties again. Just make sure that's being covered. If it's not totally being covered, I'm holding down Q here to move into my transform mode. There we go. That doesn't have to be hugely accurate. That's just going to cut out the other thing. And I can turn off the track there because I don't really need to track it anymore. So turn off the tracking in the layer controls. And we're going to do the same trick as we did in exercise 11 of unlinking our track, our background track here. So hit none, and this is just going to track through. Let's turn the surface back on here, and we'll push our surface right out to the edges. Don't really need to do that for this, but just so we can see what's going on. And I'm going to track this forwards just a little bit, and you can start to see on the surface what's going on. Let's pause that a second. We can see it's zooming out and tracking around, and that's fitting in quite nicely. Now also have a look at what's going on the timeline down here. You can see we've got an alternating stripe of blue, red, blue, red, blue, red. And remember, of course, the blue means that a frame has been tracked, and red means a frame hasn't been tracked. So what's going on here? Well, because we're working with interlaced footage, Mocha's just tracking every other field. So in this case, it looks like it's only tracking the lower field and leaving the upper field untracked. Now, generally speaking, this is fine. What can happen if you're working with fast-moving footage, or in this case, footage that's got a small judder or a small shake on each frame, is that we will lose a bit of accuracy here. What I can do is I can force Mocha to track everything and turn track individual fields on in the bottom left-hand corner of the track here. Now, if I track this through again, we'll see what's going on. It's now tracking through every field, and we can see that if I zoom in just a little bit, and let's just move up here a little bit here, just so we can see the top edge. You can see that top edge bouncing a little bit up and down as it tracks through the individual fields. If I hit escape on that there, you can now see that that's become a solid blue line. Now, as I said, generally speaking, when working with interlaced footage, this isn't necessary. It is necessary though if you do have fast-moving footage or a load of very sort of fast, small movements going on, as we've got here with the shaky camera. And I'll just let that track through. Alright, so let's have a little look here. Just make sure the track is looking solid. So again, what I'm doing is just checking out the corners of my surface here, making sure that everything's looking right. Also making sure that the surface kind of isn't bouncing around or doing anything that I don't expect it to do. So if I am happy with what the surface is doing, and I'm confident in the track, which I am here, I think that's looking nice. So what I'm going to do is just come in now, come to my camera solve, make sure I've got that layer selected, which I do, and let's come down to our camera type. And we know it's a pan, tilt, zoom. We could use auto, but generally the results that we get from auto take longer to calculate, and could be more prone to errors depending on what type of camera it is. So I like to actually specify what sort of camera motion we've got. So pan, tilt, or zoom it is. We'll check out the focal length. Again, this is just sort of relative focal length here, just to let Mocha know whether we're working on a wide angle, more middle ranges, or zoom lenses here. And I'm thinking this sort of zoom that we've got going on now is probably 35 to 70 and above 70 here. We've got a number of different zoom lengths going on because of course we've got a zooming camera, or camera that's zooming out, and it is zooming, so I'll tell it that. If I actually, let's turn it on without having zooming and try and hit solve, and it will throw up an error box that just says the camera motion does not fit pan, tilt, zoom model. Please check zooming checkbox or try a different solver. Well, we know we haven't got the zooming on. We've got solve quality of 0. Let's see what happens with zooming turned on now, and solve that again. And it will go through and it will try and calculate that camera move up for me. And after a few moments, it's now completed. It will give me an estimate of the solve quality, and it's fairly confident of what we've got there. So our solve quality is 99%. We can export out the camera data. There's a number of different ways. So we've got FBX, so we can take that into certain Autodesk products, or we've also taken it into Nuke as well. Or we can do an After Effects 3D motion data here. Again, I'm going to copy that to the clipboard, and let's have a look at it in After Effects. Okay, so I've got my clip now in After Effects here, and if I've got the Mocha camera plugin installed, when I go to Edit, I've now got underneath my Paste Mocha mask, I've got a Paste Mocha camera. So let's paste that in. So that will then give me a camera with loads of keyframes on it, and it will also generate up a number of null objects, 5 in fact, for this one. And let's turn this to Seafoam so we can see. Actually, Seafoam probably not the best choice. Let's turn this to a cyan instead. That's better. And we can use these null objects for a couple of different things. One of them is going to check whether our track is actually fitting in or not. If we can see any significant drift in the null objects, then things have gone a bit awry. The other one, of course, is to help us place objects. And let's just check out to see whether this has actually worked. So I'm just going to add a bit of text, test, put that into 3D space and shift it back where I want it to be. And let's just RAM preview that up. And that seems to be fitting in quite nicely. Let's see what happens if we add a new solid here, and we'll call this one particles. We'll add some 3D particles, see what goes on there. I'm going to use a swarm of fireflies as a preset, just for particular from Trapcode. We're not seeing anything, and I think that's actually because our camera position is so far away. Let's take a look at the visibility. Yeah, so our camera position here is minus 33,900, and all of the particles are disappearing about half that place. Right, so if I add, there we go. So if I change the visibility there, we're now rendering those up. And let's change my emitter. Let's move that over here. Change the size a little bit. Change the number a lot. And do a duplicate of that one. Just so I can come over here and really bring this one a lot closer to the camera. Let's have a little RAM preview of that one. And that's working out quite nicely. I mean, that's just add a bit of motion blur to these. And that's really the advantage of having a 3D camera solve, is once you've done a whole load of tracking once, you can easily just sort of stick in multiple objects and just reposition those in 3D space and have it all fitting in nicely. Great, so that was looking at, well, interlaced footage and how we do a basic pan, tilt and zoom camera solve. In the next exercise, we're going to be looking at a moving camera and some of the challenges that those are going to give us. But I'll see you in exercise 13.